A company has set a goal of developing a battery that lasts 5 hours, which is 300 minutes in continuous use. And a first test of 12 of these batteries measured the life spans in minutes. Okay, so the first thing we have to do when we're given a list of data is put it into our calculator. So you need to open your calculator, and in Stat Edit, you need to enter these values so that we can get the information we need so we can do the one sample t-test. We are no longer using a normal model. We are using a t-model with a t-score and a t-test and t-interval. So in the calculator, Stat Edit, L1 is the data we used in yesterday's problem. I'll enter it in L2 just to keep it in there, not that we need it. Stat Edit is where you go to do this. Oh. All right, so you should have 12 values in your list. Whether it's list 1 or 2 does not really matter. If we're going to do a 90% confidence interval, we need to do what first? Check our conditions. We don't have hypotheses for a confidence interval, but we need to check our conditions. Our first condition is randomness, just like in the last chapter, or representative. So we're going to assume the batteries are representative. Because it doesn't tell us that they're randomly selected. We still need 12 to be less than 10% of all batteries. And my third condition is no longer success failure because we do not have a proportion of success and we do not have proportion of failure. We can't check NP and NQ if we don't have a P and a Q. So our condition is nearly normal. To check that, we look at the normal probability plot of our data. So when we go back into our calculator, we're going to check for nearly normal. So in my calculator, I go to second stat plot. And my first plot, make sure it's turned on and make sure your other ones are turned off. I can check a histogram. If the histogram is pretty much unimodal and symmetric, you can call it nearly normal, but I prefer the normal probability plot, which is the last one, because there's less judgment call. The normal probability plot, if it's straight enough, then a normal model is appropriate. Okay, so I'm going to select that. My data is in list 2. And then I'm going to hit zoom 9 for zoom stat. So this is my normal probability plot. That's a really bad picture. But I draw a picture of it. It's pretty straight. Okay. It's straight enough. Okay, so we say the normal probability plot if it's straight enough, The data is nearly normal. Yes, you have to draw the graph. If you draw a histogram, you have to sketch the histogram. It doesn't have to be a perfectly accurate graph. It's a sketch, just to show what you saw in your calculator. Okay, now this normal probability plot allows us to use the T model for this test. Layla.
Do you want us to write that sentence in nominative?
Yes. You have to define what it is about that graph that you are using and why you're looking at it. It must be straight enough. If you're looking at a histogram, you want it to be unimodal and symmetric. I like, again, this normal probability plot because it's more straightforward. I don't have to manipulate it. The histogram, sometimes you need to change the window to make it look better, and you don't have to do that with the normal probability plot. Now, if both of them are curved, but our sample size is large enough, we can still continue using the central limit theorem. Remember that if n is greater than 25, then you can use the central limit theorem to proceed. But our graph is straight enough, so we're good to go. So since conditions are met,
Some pretty ones.
oh, thank you.
Nice set.
Awesome.
Only 32 in here.
AT model is appropriate. I will use a one sample t interval. Be specific. This asks me to do an interval. I'm going to use an interval, and I want you to state the degrees of freedom. Degrees of freedom is your sample size minus 1 with 11 degrees of freedom. That's our T model. T model with 11 degrees of freedom. Now my calculation is x bar plus or minus my T star with 11 degrees of freedom, with the sigma or s, the standard deviation, over the square root of n. Sample size n minus 1 is our degrees of freedom, which is 12 minus 1 equals 11. You need to make sure you watch yesterday's video if you were not here. Okay. Now, I don't know mean or standard deviation, so I have to find it. How do I find it? 1var stats. I need to go to 1var stats to find my mean and standard deviation. Aiden, do you have a question? Okay. My battery is low. So I need my statistics. Stat, calc, 1var stats, list 2. I have no frequency list, so that stays empty, and I hit calculate. So my mean is the x bar, and Sx is the standard deviation I'm going to use. I do not use sigma. I use S. Okay. The 11 is going to come in when I find my critical value. So the 11 comes in when I have to find my T star. What is T star with 11 degrees of freedom? Well, we're going to go to our table to find our T star. The table is in the back of the book. The table is in your modules under tables. I wanted 90% confidence. This is the table that says table T. Find the bottom. Oh, wait. This table is table T. I'm going to find 90% confidence, and I'm going to go up to 11 degrees of freedom, which is 1.796. So that is my T star. It's no longer the values that we used in chapter 19. because with a T model, it varies depending on the sample size. So 1.796. And then I can create my interval, which is my sample mean, 306.25 plus or minus 1.796 times sigma over square root n, 29.31 over the square root of 12. So in your calculator, oops, 29.31 divided by the square root of 12 is 1.796 times 8.46. So it's 306.25 minus 1.796 times 8.46. I get 291.06. And then I do the addition. I get 321.44. And I interpret my interval. You always interpret your interval. If it doesn't specifically say to interpret your interval, you interpret your interval. You miss out on an entire point on the AP exam if you do not interpret. Every confidence interval is conditions, 1 point, your actual calculations, another point, and then the interpretation is a third point. That's all that was. Yeah. Okay, so this statement's not different from last chapter. Oh, it's not 95%, it's 90%. The only difference is we're talking about a true mean, not a true proportion. We're not talking about proportions now, this unit. We're talking about means. The true mean battery life is between 291.06 and 321.44 seconds. Make sure you include your units. Minutes, sorry, it is minutes. Minutes. Now, what's the second question on the... Is there evidence that the company has met its goal? Use our confidence interval to test an appropriate hypothesis. So your hypothesis would be that x bar, be that mu, is equal to 300. Is there evidence that 300 is a possible mean for these battery lives? Yes. What would the alpha level be for 90% confident? 0.05. 90% confident has 5% in each tail. The tail probability is the alpha level. So for 90% confident, it's 0.05. It'd be 0.05. If it was 99% confident, then your alpha would be 0.005, right? 0.5%. Yes, 95% would be 0.025. Yeah, 2.5%. Okay, so yes, there is evidence that the company has met its goal because 300 minutes is within our interval. Because we created that 90% interval, our alpha level was chosen for us by the fact that we're making a 90% confidence interval. So in the end, because 90%, a confidence interval is two-sided, right? There's 5% on each side and the 90 is in the middle. So that confidence level of 90% means a 5% alpha level. A 95% confidence level means a 2.5% alpha level, 0.025. Because that's how much is left in the tails, because the 95% is in the middle. It's not the bottom portion of it, not the whole bottom portion. Okay? So our alpha level was chosen for us by the fact that it gave us a 90% interval as what it wanted us to do. Okay, yes.